Good morning, everyone. It's time for biology. So today we're going to learn about tools and procedures, basic tools that any scientist can use, whether it's biology, chemistry, physics. So before we get started, I want to make sure you have a couple things. If you could have just a pen or pencil, two kinds of rulers. We need the ruler with the metric and the ruler with inches. So go ahead and get those. And then you need to take some notes on something. There's a regular notebook with just lined paper, and then this is a science journal, and this is a really good thing to use for lab reports, and the pages stay in there and you can use it for references and studying. So I kind of like this one best, but you can use what's convenient for you. So today we're going to talk about tools and procedures. Now I want you to look at this picture, and for about 30 seconds go ahead and look and see what is the most dangerous thing in a science lab. And so hopefully some of you have been in a science lab and you know about different dangers. So go ahead and think for about 10 seconds. Okay, did you get some? And when you're thinking, it's okay to be writing things down. And throughout today's lecture, we're going to write a lot of things down because sometimes it's easier to learn while we're actually interactive, and you're going to be measuring some things today. So it's important to write things down. Did anybody say fire? Fire is a big danger. Maybe cutting yourself, maybe electrical shock, maybe something with needles. Okay, now to get you interested, I want you to watch this little video. It's of a little kid, but hopefully it'll help you understand. So let's get started.
Can you look at these two glasses? Do you think that they have the same amount of juice?
It's about 3 minutes.
You think they have the same? Okay.
What do you think?
Now we're going to pour this juice into this glass.
Okay, watching.
Now, do you think that this glass has more juice? This glass has more juice? Or do you think that they have the same amount?
What do you think?
This one has more, and why do you think that this one has more?
Because it's taller.
Ah, taller.
So first we're going to look at these two cups right here. Do you think there's the same amount of juice in this glass as there is in that glass? They're even? Okay. So we're going to take the juice from this glass and pour it into this one right here.
Make sure you can hear it well enough.
Okay, so now we're going to look at this glass and that one.
Oh.
So do you think that there's more juice in this glass, more juice in this glass, or do you think that they have the same amount?
What do you think?
Same amount.
Okay, why do you think that they have the same amount?
Just because this is skinny doesn't mean it's not the same amount. It has the same amount of juice in it, but this one is just wider and this one's skinnier.
Future scientist.
Okay, you ready?
Here's another one.
Okay. Does this row have more quarters? Does this row have more quarters, or do they have the same?
1, 2, 3. Wait. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. They're both the same.
They're the same?
5, 5.
Okay.
Keep watching.
Okay. Does this row have more quarters? Does this row have more, or do they have the same?
This one has more.
That one has more quarters? Why does this row have more quarters?
Because it's more far away.
It's more far away.
She's confused.
It's like more far away than like that. It's like bigger.
Is it bigger?
All right, we're going to play a game with the graham crackers, and we're going to share them between me and you, okay? Okay.
She's excited.
Do you think that we shared those fairly?
No.
No, why not?
So as you can see, understanding volumes and measurements can be very difficult. So today we're going to just start with some basics. The first one is called the metric system, and it's a system that scientists use all over the world. In fact, there's only a few countries that don't use the metric system all the time, and America is one of those. But this is how all scientists communicate with each other around the world. So it's really important that we use metric. So let's talk about length first. Length is measured in meters, centimeters, millimeters. So I want you to go ahead and pick up your centimeter ruler and lay it on that. If you'd like, lay it on the screen, or if you would like to just use your eyes and tell me how big is this pill bug. And the pill bug is, sometimes they call it roly-polies. They live under rocks. They like water. Anyways, what do you think the length is? Give it a look and write it down. Okay. Did anybody put 6 centimeters or millimeters? So you have to look really close in, and between here and here is centimeters. So if we look closer, those smaller ones are 10 millimeters, and this looks like this bug is about 8 millimeters. Okay, now we're going to look at snails. So go ahead and just look with your computer, or if you notice, is it exactly the same? No. So the centimeters on the screen are bigger than the centimeters in your hand. So go ahead and just look at it, and I'd like you to go ahead and let's look at this first one. Okay, write it down. All right, let's look. It looks like 1, it's more than 2. Bring it down. Sometimes when I'm measuring, I like to bring a straight line down, and it looks like it's about 2.3. And that would be centimeters. Okay, go ahead and look at the second one and take a look at it and write it down. This one's a little trickier because they're not starting at 0, they're starting at 3. So let's have a look. Okay, it's 1, 2, 3, 3.5. So remember, it's from 3 to 6. And then a half more. And then the last one, oh, even more tricky because now they're starting at 8.3 and it's ending at 10.8. You might have to get out the pencil and put 10.8 minus 8.3, and there you have it. All right, now, again, you might have learned how to measure in America using this, which is a ruler, and it's inches. So if you look at this top snail, you can see that it's more than an inch. In fact, it's, again, if you use a straight line, you can say it's about 1 inch and 1/8. That's the American way, but that's not the scientific way. And then on the second one, you use your centimeters, and it does it there, and we started at about 1, and it goes to about 3.5. So then you have to say, well, which one's bigger, which one's smaller? In order to say which one's bigger and which one's smaller, we have to use the same unit. So let's go ahead and use it with centimeter ruler, and we'll see which one is bigger or smaller. And it looks like this is less than 8, and this one is also less than 8. In fact, they're almost the same size, but we use different tools. So that's measuring length. All right, next I would like you to write volume in your notes. And volume is measured in liters or milliliters. And in America, this is much easier to understand because we buy things in the market like 2 liters of water or 1 liter of water or a liter of Gatorade. And so it's easier to measure. It's easier for us to understand how that works because we use that. Now, we still use gallons of milk, but in other things like water and soda, we use liters. And the definition of volume, you might have already known this, is how much space something takes up. It's usually a liquid, and you can use a beaker or graduated cylinder. I'm going to remind you that this PowerPoint will be available so that if you need to take more notes or you need to go back and get some notes, it'll be available. We'll download it onto the classroom. So when you look at it, one thing you notice is that the meniscus is bending as it goes up the graduated cylinder. So whenever we're reading a meniscus, we always want to read it at the lowest amount. And again, since we're using a computer, it might be easier to take your ruler and go across, and that's going to be 42. And then we have to look right here for the units, mLs. And again, this is how we view soda pop and water, so you probably recognize it. All right, volume for solids is different, and that's going to be length times width times height. So length times width times height, it's called a cube, and you multiply 2 times 4 times 6, and that would get you the volume of a solid. Another way we often use in science is called volume displacement of water. So we would put a set amount of water in a graduated cylinder, let's say 30, and then we drop something in it, and how much the water goes up or is displaced will tell you how much the volume is. So let's look at this one. It started at, look at it. Do you see it? Yeah, 30. And now look, it ended at 40. Well, we didn't add any more water to it, so it means that this little stone pushed the water up or displaced it, and that's right, for 10. Next is mass, and if you've worked in a lab at all, this is called a triple beam balance. And the reason it's called triple beam is it's got 3 beams. And so we always start with our bars all the way to the end, 0, 0, 0. And these are pretty fun to use. Now, if it's really small, we measure it in grams. If it's bigger, we measure it in kilograms. So grams is small. Maybe you've heard of like medicine. And then kilograms is large, like the man weighed 102 kilograms. So go ahead. It says, how many kilograms is your teacher? Well, take a look. Can you guess? Kilograms. And some of you are like, I have no idea what a kilogram is. But anyways, we're going to get used to using it throughout the year. Now, if you look at each one of these beams, the beams will tell you how much. So we always start to read this with the biggest beam. And the biggest beam is 200. So we know it's going to be 200 and something. Then we go to the next. So we got hundreds. Now we want tens. That's ones. Oh, here's tens. So that's 200. And look at the number underneath. What is it? It's 70. So 270. Now let's go down to the bottom one, and this will tell us our ones. And that's 272, but it's not exactly at the 2. So you look in really close, and it's 1 past 2, so that's going to be 0.1. So the answer would be 272.1, and we're using grams. Another thing we want to talk about is temperature and how to measure temperature. Here in America, we use what's called the Fahrenheit system, and around the world, we use a Celsius system. So maybe you've seen a thermometer where it shows both sides, and so it's kind of easier to understand. If you think about it, is it warm outside? Maybe it's 80, maybe it's 90, so look at this yellow one. And on the right side is Fahrenheit, and we know that because there's an F at the bottom. And then on the left side, it's the same, it's just the same red line, but now we know we're in the Celsius. So they're very different. On this one, let's go ahead and read it and write it down. What is it in Fahrenheit on this classroom thermometer? So look in close, write it down. So what do you think? Did you guess about 88 degrees? Good job. And now with the same idea, but in Celsius, we look and it's 30, about, write it down. Did you get it? It's about 31 degrees Celsius. Now in science, it's always important to write your unit of measurement down. So it would be Fahrenheit or it'd be Celsius, but it's very important. Now let's look at the big clock. And this is how you can sometimes find them with the big and smaller. So let's look at the big one, which is, look for it. Is this Fahrenheit? The big one, is it Fahrenheit or Celsius? And so I look for a clue. Bam, right there, it's Fahrenheit. And so we could say in Fahrenheit, it's 70 to 70. It's almost 74, not quite. And then go ahead and look closer in. You might need to lean into your computer screen, but this one is Celsius. And this one is different, and it says it's 50. Now, it's not really 50. So this one is only Celsius. But if you look inside, there is another units, which is Celsius, because it tells me right there, and that's about 20 to 1, 2, 3, about 23. So you get a feeling. Now, just in regular system of Fahrenheit, we have boiling at 212 and then we have freezing at 32, which are kind of odd numbers. And that's why scientists use it Celsius, and boiling is 100 degrees and freezing is 0, which are easier numbers to work with. And we'll continue this lesson on. Thank you.